Alright, nerds, so, Miss Martinez told us to, memorize this formula, and I'm like, how do we prove this thing? So clearly, you could really easily use induction to prove this, but come on, that is boring. I don't want to do that. So, let's prove it without induction. So, what we're going to start with is we're going to start by looking at this sigma notation. So that would be I equals 0 up to n. Actually, you don't have to start at 0. I just want to start at 0. We can start with 1, 2. I plus 1 squared cubed minus I squared cubed. So, what do we do from here? Well, let's look at this thing. This is a telescoping sum, obviously, because if we write down all of these things, we end up with starting from I equals 1, 2 cubed minus 1 cubed plus 3 cubed minus 2 cubed plus 4 cubed minus 3 cubed, blah, 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 plus n plus 1 cubed minus n cubed. And what do we end up with? We end up with, this doesn't cancel. This cancels out. This cancels out. This will cancel out. This will cancel out. All we end up with is this. Boop. That is all we end up with. So, what you can essentially do is we can just write this as n plus 1 cubed minus 1. Bop, bop. So, that is our thing. Now what? Well, notice how we can also do this. Let me just quickly do I plus 1 squared cubed minus I cubed. This also equals to I squared I cubed plus 3I squared plus 3I plus 1 minus I cubed. And what's happened here? This is equal to I equals 1, 3I squared plus 3I plus 1. Look at that. So, what do we have here from now? We can simply write this as equal to 3 I equals 1 and I squared plus 3 I equals 1 and I plus 3 plus I equals 1 and 1. And all this is equal to, and how about this? Let's set what we want to find, like this thing. I don't want to write this every single time. Let's set this equal to s. We have 3s plus 3 n plus 1 over 2 plus n. Now what? Well, we know that this is equal to this thing right here, right? So let's write down n plus 1 cubed minus 1. Now what? So clearly what we can do now is we can simply, let me just get rid of all this here so I have more space. Let me just write this down. Yeah, right, 3s equals to n plus 1 cubed minus 1 minus n minus 3n n plus 1 over 2. Perfect. Now let's just expand this. So this is equal to n squared plus 3n squared plus n cubed plus 3n squared plus 3n plus 1 minus n minus 3n squared plus 3n over 2. Wow, that's a lot. So, but this cancels out. This turns into a 2n. And let's just split this up into here. It's 3n squared. Actually, nah. 3n squared plus 3n over 2. And all that, when we plug in everything together, we get 2n cubed plus 6n squared plus 4n minus 3n squared plus 3n, actually that's minus since it's like brackets, over 2, which is equal to 2n squared cubed plus 3n squared plus n over 2. Now, what is n plus 1, 2n plus 1, that thing we just have up here? Well, if we factor it out, we get 2n cubed plus 3n squared plus n. Oh my god. Isn't that exactly what this is? Right? Oh my days. And now but it's a 6 over here. We have a 2 here. What do we need? Oh, we need a 3. Where can we find a 3? Oh my days. Oh, it's right here. We just divide the 3 over, and we get s equals n plus 1, 2n plus 1 over 6.
QED